Okay, dear students, we can discuss exercise questions. Exercise 1.1. The first question. The first question is using Euclid division algorithm. Find the HCF of the numbers. I already said to you that we are using Euclid division algorithm for finding the HCF of the numbers. Here, the first question is find the HCF of 135 and 225. When we compare the 135 and 225, 225 is greater than 135. So first we want to write like this way. Largest number first we want to write 225 is greater than 135. The next step is divide 225 with 135. We already discussed that if you divide A is an integer, B is another integer. If you divide A with B, you will get quotient Q and the remainder R. Then you can write A equal to BQ plus R. Same way we are writing 225 is dividend, 135 is divisor. So the quotient is 1 and the remainder is 90. So we can write this 225 is equal to 135 into 1 plus 90. You look here. We want to get the remainder as 0. Here the remainder is 90. So we want to repeat this process. Now the new dividend is 135 and the divisor is 90. Then divide 135 with 90. 135 divided by 90, that is 1 time 1 into 90, 90, the remainder is 45. So we can write 135 is equal to 90 into 1 plus 45. 135 equal to 90 into 1 plus 45. Here also the remainder is not 0. Here is a non-zero number 45. So we want to repeat the process again. That is, we want to consider this 90 and this 45. Then divide 90 with 45. What is 90 with 45? The quotient is 2 and the remainder is 0. Then we can stop this process. That is, you can write 90 equal to 45 into 2 plus 0. So this is the final step. 90 equal to 45 into 2 plus 0. When the remainder is 0, that time what is the divisor? The divisor is 45. That is the answer. When the remainder is 0, the divisor is 45. So the HCF of the two numbers, HCF of 225 and 135 is 45. Second question is 196 and 38220. Here very clear, 3822060 is greater than 196. So 38220 is dividend and 196 is the divisor. So divide 38220 with 196. In the first step is finished. 196 into 195 0. So this is the final step. 38220 equal to 196 into 195 plus 0. Here now the first step the remainder is 0. When the remainder is 0, what is the divisor? That is the answer. When the remainder is 0, what is the divisor here? 196. So what is the answer? HCF is 196. Moving to the third question. Third question is 867 and 255. 867 is greater than 255. So 867 is the dividend, 225 is the 255 is the divisor. So 3 times it will go. 3 into 255 is 765. The remainder is 102. So the remainder is 10. So we want to repeat 102 and 255. Now the dividend is 255 and the divisor is 102. So 255 divided by 102, the quotient is 2 and the remainder is 51. Now again the remainder is non-zero number. So we want to take this 51 and 102. So the third step is 102 divided by 51. That is 102 divided by 51 is the quotient is 2 and the remainder is 0. Now the remainder is 0. At that time, what is the divisor? Divisor is 51. So what is the answer? Answer is 51. This is the last step. Here the divisor is the remainder is 0. So the answer is 51. The next question is show that any positive odd integer. Look the sentence. Odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5. Any odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5. So this type of question, let A be, the answer is let A be any positive integer, divide A with 6. Suppose the question is 5q plus 1 something. We can take A and 5. Here the question is 6q plus 1. So we are taking A and 6. So divide A with 6. The quotient is q and the remainder is r. So A equal to 6q plus r, 0 less than or equal to r less than 6. So this the value of the r can be 0, greater than 0, but it must be less than 6. So you can write A equal to 6q plus 0, that is 6q. A equal to 6q plus 1, A equal to 6q plus 2, A equal to 6q plus 3, A equal to 6q plus 4 and A equal to 6q plus 5. Look here, a equal to 6q. It is even number or odd number. It is even number or odd number. What is the difference between the even number and odd number? The number we can completely divisible with 2. That type of the numbers are known as even number. If you can't divide with 2, that type of numbers are known as the odd number. Here 6q. We can divide 6q by 2. What is 6q divided by 2? 3q. So it is even. Look at the next one. 6q plus 1. 6q by 2 is possible, but 1 by 2 is not possible, so it is odd. And look here, a equal to 6q plus 2. 6q by 2 is possible, 2 by 2 is also possible, so it is even. And look here, next one, a equal to 6q by 3. 6q plus 3 all divided by 2. 6q plus 3 all divided by 2. 6q to 3q, but 3 by 2 is not possible. So 6q plus 3 is odd number. It is odd. And a equal to 6q plus 4 is completely divisible with 2. So it is even. And a equal to 6q plus 5 is not divisible with 2. So it is odd. So which are the odd one? 6q plus 1 is odd. 6q plus 3 is odd. And 6q plus 5 is odd. So we want to conclude the answer. Therefore, any odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5. Okay, students, with the next question, an army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of column. The two groups want to march in the same number of column. What is the maximum number of column in which they can march? I think question is hopefully understood. Here the given numbers in the question are 616 and 32. So the answer must be less than 616. So we want to take SCF. Okay. The one side of the question, 32 members in a band group and 616 members in a army contingent. So they want to march in a column base. So what is maximum number of columns? So the answer must be less than the given largest number. The answer must be less than the 616. So we want to take SCF. The SCF of 616 and 32. We can use any method for finding the SCF. Here we are using the Euclid division algorithm. 616 equal to 32 into 19 plus 8. Here the remainder is not as 0. So we are again taking 32 and 8. 32 equal to 8 into 4 plus 0. Now the remainder is 0. At the time the remainder is 0, the divisor is 8. That's why the SCF is 8. So we can conclude the answer, that is the maximum number of columns is equal to 8. Okay students, this is the last question from this exercise. For the question, n is any positive integer. Prove that n can be expressed in the form 9m, 9m plus 1 or 9m plus 8. This question can be asked in a different method also, but we are taking this method. So the same way, the last question, the same way we are repeating. A equal to a divided with 3. So what is the quotient? Quotient is q and the remainder is r. So a can be expressed as 3q plus r can be 0, r can be 1, r can be 2. So three possibilities: a equal to 3q, the first method; a equal to 3q plus 1, the second; and the last case is a equal to 3q plus 2. What is the question? Cube of any integer, that's n cube. So we want to take cube. We want to take cube on both sides. So here a equal to 3q. Taking cube on both sides, a cube equal to 3q whole cube. What is the cube of 3? 3 into 3 into 3. What is 3 into 3 into 3? 27. 27 q cube. Here 27 we can write, actually 27 is 9 into 3 is 27. So a cube equal to 9 into 3, that is 27, this q cube. We want in the form 9m. So 9 into something. This something we are taking as m. So we are expressing a cube equal to 9m. So the first method is okay. Second is a equal to 3q plus 1. We are taking the cube on both sides. 3q plus 1 whole cube. What is a plus b whole cube? A cube plus 3a square b plus 3ab square plus b cube. So when we are taking the cube of 3q plus 1 whole cube, the first 3q whole cube, that is 27q cube. Then 3a square b, 3 into 3q square, that is 3 into 9q square, that is 27q square into 1, 27q square, plus 3ab square, that is 9q plus 1. Here from the first three terms we are taking the 9 as the common. So 9, we are taking 9 here common. So 9 into 3q cube, 27q cube, 9 into 3q square, 27q square, 9 into q, 9q plus 1. So this one we are taking as m. So we are expressing a cube equal to 9m plus 1. So this part is also over, this part is also over. The next is the 9m plus 8. What is the third chance? a equal to 3 cube plus 2. Same way we are taking the cube on both sides. A cube equal to 3 cube plus 2 whole cube, that is a cube equal to 27 q cube plus 54 q square plus 36 q plus 8. From the first three terms we are taking 9 as common. 27 is 9 into 3, 54 is 9 into 6, 36 is 9 into 4. So 9 into something plus 8, this something is 8, we are taking as m, so a cube equal to 9m plus 8. So we are expressing in the form 9m or 9m plus 1 or 9m plus 8. So cube of any positive integer is of the form 9m plus 1 or 9m plus 8. This is the last question from this exercise.